These are the most frequently asked questions for algebra section 1, 2, and it's never so much because you don't know how to do the math, but more because the instructions confuse people. So as we're looking at number 23 here, it says we're supposed to compare these using either the greater than or the less than symbol. So what you have to do is first evaluate the numbers and figure out what they are. 16, but the square root of 16 is 4. So pretty obviously 16 will be greater than 4. So there's your comparison. Otherwise, you could certainly flip them around and say 4 is less than 16. We just need to compare those two numbers as we go through and look at those problems. In 23 through 34, they want you to ignore this and just go ahead and use numbers in the order that they're in. So for number 24, we have -4 and a negative square root of 4. So there'll be -4 and -2. And -4 is, of course, to the left of -2 on the number line, so -4 is less than -2. And again, they just want us to write these one directionally and basically just tell them this is greater than and this one is less than. So those are their instructions for those. Then down here, usually, this is just a matter of having forgotten some of the geometry from last year. When you look at 35, you want to think, what changed from this step, the step I underlined in the red, to the green? And what you notice is that there's no parentheses anymore. So you take a second look and you think, well, what happened to them? Well, they multiplied pi times each of these terms to get that to happen. And when you multiply it twice through parentheses, that's called distribution. So this is the distributive property of equality, because we have an equal sign in here. So that would be the property of real numbers that's used for number 35. For number 37, we take a look at this one and we notice that the parentheses are still there, but they're around something different. And that's because when numbers associate with each other, we use grouping symbols to show that they're hanging out with each other. So here, the set of parentheses is around the 2 times the square root of 7. And here, the parentheses are around the square root of 7 and the square root of 3. So for number 37, that's going to be our associative property for number 37. And because we have this little multiplication symbol right here, this is the associative property of multiplication, right there. Then we go to I'll jump down to 39, and number 39 is showing how when you take something and you add 0 to it, you just get the number back, And what's happened is you have not changed the number's identity. You didn't change what the number was. It was the negative square root of 5. You added 0 to it, and you got negative square root of 5. And that is, 0 is called the additive identity. And I will let you take a look at 36, 38, and 40 and see if you can match that to those properties that we had before in the book, and see if you can get those. Otherwise, those I can answer in class if anybody still needs help with those. Then it's the same thing as far as 41 to 47. People are looking for an exact answer on these, and notice this says estimate. Some of them, yeah, you can see, hey, point A here, that's going to be -5. That is the coordinate for point A. But something like point F right there, you just have to make your best guess. I mean, I'm looking at it and I see that it's more than 3. So for point F here, it's going to be 3 and something. Doesn't quite make it half of the way across, so maybe I'd say like 3 1/3. But this is an estimate, so as long as you're reasonably close, you're going to be just fine. Down here, number 49, it says we've got a cube-shaped jewelry box. So the first thing you need to do is think of what a cube is. And a cube is a box that's made up of squares all the way around it. So all of these side lengths are going to be exactly the same thing. So if it has a surface area of 300 square inches, well, you have to think there's going to be how many blocks that'll look exactly the same. Well, we have our front, and then there would be one in back. We have a right and a left side, and a top and a bottom. So there are actually 6 squares that make up that surface area of 300 square inches. So if we take 300 and we divide that by our 6 squares, we're going to get 50 square inches for each of those squares that are sides of this cube. So if this is 50 square inches, we're supposed to work backwards and figure out what the dimensions are. And again, it's a square, so those are the same. So you think, all right, well, I don't know what it is. I'm going to make that x. But wait a minute, then this will also be x because they have to be the same. So x times x, which is x squared, has to equal 50. And to solve that, we would take the square root. So it would be the square root of 50. And now I want to check and see, what exactly did they want to know? Well, they want the dimensions. So they're probably going to ask me to figure out what it is with a calculator if it's something I have to do more math with. But in this case, they just want to know what are the dimensions. And there isn't a more perfect answer, a more exact answer than just stopping and say, you know what? It's the square root of 50 inches. That's exactly what it is. If we use a calculator, we're going to be rounding, and we won't have an exact answer. So all the dimensions are going to be the square root of 50. So that means this is the square root of 50 inches by the square root of 50 inches by the square root of 50 inches. And that would be the cube, the dimensions of the cube, that would give you a surface area of 300 square inches for that one. Next one on the list has to do with this science formula. I equals the square root of W over R, and there are a whole bunch of problems down below that they want you to use. And for number 51, it says we're going to use W as 100 and R as 25. And literally what they want you to do is just use this formula and get an answer. So I equals the square root of W over R. That would be the square root of 100 over 25. So then you do the math, and square root symbols are like grouping symbols. You have to do what's under them first. So 100 divided by 25 is 4. And that means our answer is 2. And then we want to go back and look for a label on those. And the label there. Oh, here it is in the reading. They don't even want us to figure out what the label is. What we're supposed to do, because I is in amperes, and I'm going to go ahead and label it anyway because it kind of drives me nuts not to. But we have 2 amperes, and what they want us to do is figure out which set of numbers that value would fit into. So once I have the answer, I'm supposed to figure out the subset of numbers that belongs to. 2 in, again, the most basic form, we want to fit the category that's the smallest that would fit into. That's going to be a natural number because that's a counting number. And that's what our natural numbers are. They're our counting numbers. So we use the formula, get an answer, and then check and see where that fits into our sets of numbers. And like I said, there are several of these. So this was the first one. Again, just find the answer, figure out what set of numbers we're going to use to best describe that. Then Counterexample. This was from geometry last year. Counterexample is a statement that makes a general statement false. So let me show you how this goes. Show that each of the following statements is false by just giving a counterexample. Well, it says the reciprocal of each natural number is a natural number. So I start thinking about the natural numbers, and the first one of the counting numbers that comes to mind is 1. But I take the reciprocal of that and I get 1, and that is a natural number. So that's not a counterexample because it works. I don't want that one. So then I think about 2. All right, well, 2 is definitely a natural number. If I take the reciprocal of 2, I'm going to get 1/2. That is not a natural number. So 2 would be a counterexample of the reciprocal of each natural number is a natural number. And again, that's because if you flip it over, you get 1/2, and 1/2 is not going to be a natural number. 61 says the opposite of each whole number is a whole number. All right, so again, you start thinking. We need a whole number here, but we need a whole number where the opposite is not a whole number. So with number 61, you just go through them. Think about 61. The opposite of 0, well, we don't really have an opposite of 0, so you can't use that. So that's out. Think about 1. Well, the opposite of 1 is -1. So the opposite of the whole number 1 comes out to be -1. And -1 is not a whole number. So 1 would be a good counterexample for that one. 62 says there is no integer that has a reciprocal that is an integer. There is no integer that has a reciprocal that is an integer. And for 62, so what we want to do is find an integer that does have a reciprocal that is an integer. Well, integers start with a negative, so I guess I'm going to go ahead and do probably one of the most basic integers you guys could think of, which would just be -1. And what we want is the reciprocal of -1, and the reciprocal of -1 is -1. So that is an integer. And -1 would be a counterexample. Number 63 says the product of two irrational numbers is an irrational number. Well, the square root of 2 is an irrational number, and it's the first one that pops into my head because it's the one that's used for an example in any math book that you have. Well, if I take the square root of 2 and I multiply it by the square root of 2, I get the square root of 4, which is 2. And 2 is not an irrational number, it is a rational number. So that means that the square root of 2 is a good example of a counterexample for that one. Then 64 says all square roots are irrational numbers. All square roots are irrational numbers. Well, in the last problem, I just used the square root of 4, and the square root of 4 is 2, which is a rational number. So this would be a really good counterexample for number 64. Now we get down to number 66, and it says 5 friends each ordered a sandwich and a drink at a restaurant. Each sandwich costs the same amount and each drink costs the same amount. What are the 2 ways to compute the bill? Okay, well, first off, you could say there's 5 of them. Just figure out how much a sandwich plus a drink costs. Figure that out and then multiply by 5 and you'll get it. And somebody else might say, well, no, I'm going to do 5 times the cost of the sandwich plus 5 times the cost of the drink, and that'll give me the total. And then as it says here, what property of real numbers would allow that to happen and give you the same answer right there? And that's going to be the distributive property. Because I multiplied that 5 through the parentheses and ended up with the same answer. So it doesn't matter which way you do it. That is it for the frequently asked questions.